Hello, in this session we will understand k-means clustering algorithm. We already had covered up the algorithm, but in this session we're gonna practical it and see in the Jupyter notebook. Okay, and for that reason, let's start it. So the first thing that I want is I need some the graph libraries like Seaborn and Matplotlib. So I'll import here. Let me just increase the um, font size. Okay, and then I'll say import Seaborn as SNS, and also I need import matplotlib.pyplot as plt, and I'll say matplotlib inline. Okay, so this is my graph libraries, uh, and what mistake I did is pyplot as plt import matplotlib.py. What is the mistake here is inline. Okay, so I just have to do this. Okay, so these are the two libraries to create our graph, and the next thing that I want is my dataset. So again I'm using the scikit-learn dataset, and I'm taking the dataset make blobs. Okay, so from sklearn dot datasets import make blobs. Okay, so this is the data set that I want, and from this data set I will create my data here. Okay, so what kind of data I want? So I'll say data equals to, so I'll use make blobs, and inside that I'll say what exactly this make blobs need is you can press shift tab and can see that it needs samples and then it needs features. Okay, so you can provide the samples here and then you can provide the features here. Again it needs cluster standard deviation, so I'll provide 1.5 here, and also it needs how many centroids, or you can say the cluster centers you want. So if you want like 2 clusters, then provide 2. If you want 3 clusters, then provide 3. Okay, and based on that your feature is based on that your label is going to come over here. So what I gonna, you please go through this complete documentation on that and can check it out what kind of thing you want here. Okay, so here you can see here n samples it had taken in the list, then center is no, feature is 2, and random state equals to 0. However, this random state is basically if you want the same output as mine, then you provide the same random state as I'm taking. Okay, so if I'm taking 100, then you please provide 100 in your demo. So I'll use n samples equals to 100, and then I want n features, I'll say 2, and then I need centers equals to 3, and I'll say cluster std equals to 1.5, and again I need random state equals to 100. Okay, and I'll hit OK, and I'll say data. So if you see the data here, then it is going to be in the tuple. Okay, so I'm just writing data, and you will see that it is in the tuple. So what I can say it is this index is going to be 0 and this index is going to be 1. So you can see here if I provide data 0 dot shape and I hit OK, then it will give me the dimension. So it gives me 100 rows and 2 columns, and this is precisely seen over here, that is 100 samples and 2 columns. Okay, and you had seen in this is 0 and this is 1, so that's why we have 2 columns here, right? In the same way, if I say data 1, and data 1 basically provides you the clusters. Okay, so let me just put it one row here, and I say data 0, then this complete row is going to be cluster inside this 0. Okay, then this particular row is going to be clustered in 0. Okay, so the last row belongs to cluster 0, the first row belongs to cluster 0, the second row belongs to cluster 2 likewise. And you can see that we had taken cluster, let me just remove this because I don't think now I need where is this, yeah, so I'm gonna remove this, and now you can see here that as I already had taken a cluster 3, and that's why my output is 0, 1 and 2. So all these samples are going to be inside cluster 1, cluster 2 or cluster 0. Okay, I hope you are getting it. And now you can plot this complete thing. Let me just remove this, and I can plot this data 0 inside the scatter function of matplotlib. So I'll say plot scatter and then say data. So I need data 0, and then what I need that all rows and column 0. In the same way, I'm going to copy this because I want to show the all rows and column 1. So I'll just paste it over here and I'll say column 1. Okay, and then what else I need that it should be compared. This is my complete x. Okay, this is my complete x. So the scatter function needs x and y dimensions. So this complete is my x, and now I'm providing the other one, that is y. So I'm going to say data 1, and then I also provide CMap for coloring our graph. So I'll say rainbow. Okay, and now when I hit OK, you will see the graph, and you can see as I had 3 clusters, so that it gives me 3 colors in the cluster form. So this is cluster 0, cluster 1, and cluster 2, maybe in any order. Okay, so these are the 3 clusters. So if I say cluster equals to 4 and I hit OK, hit OK, hit OK, you will see that it will give me 4 clusters, 1, 2, 3, and 4. Okay, so for this reason, I'm just putting it over here 3. I hit run again. So this is the make blob data set, and now what I'm gonna do is I'll use the k-means clustering algorithm to compare it with the make blob data set. Okay, the labels that my data points come in cluster 0, cluster 1, and cluster 2 precisely or not. So I need k-means clustering algorithm. So it is again in the scikit library. I'm going to import it from sklearn.cluster. Okay, this is the library cluster, import k-means, and it imported the k-means clustering algorithm from the library. I'm going to use the variable k-means, k-means equals to k-means, and what this k-means function need is if you can press shift tab, then it will say that it needs the clusters. Okay, how many clusters you want. So I'm going to use that, let me have n clusters equals to, let me say 3. Okay, so k-means clustering algorithm will provide you 3 clusters. So what k-means clustering algorithm is going to do is going to take 3 clusters. Okay, it provides 3 centroids in these clusters. It will put randomly inside this graph, and then it will calculate the distance from the data point to that centroid, and the minimum distance of the data point is going to reside in that centroid. Okay, that we had seen in the demo, in the video lecture, that whatever the minimum distance, that data point come and exist in that centroid, and then after it will average it and then move it to the whatever the average it comes. Okay, so if I have a centroid over here, then this is the minimum distance between the data point and the centroid, and then what it's gonna do, it will calculate the other data point that is nearby to it, and then it will average it, and then it will move. Okay, it will move near to the data points, which are near to it. Okay, it will move it to, and we had seen that in the video lecture. Please go through it and please refer that video so that you can understand. So in this demo application, I need 3 clusters, so I had put n cluster equals to 3, and the next thing that I want is I want to fit the data. What data I want to fit? I want to fit the data 0. Okay, this data 0 is my actual data, and you had seen this is 100 rows and 2 columns. Okay, so this is my data actually. So I'm going to fit this data here. I'll say k-means equals to fit, and I'll say data and say 0. So it will fit the data. Oh, I'm so sorry. Dot fit, and I'll say k-means dot fit data 0. What actually? Oh yeah, I'm so sorry. So this is it. Okay, so k-means dot fit data 0. So it will process it and it will fit the complete data 0, and we can see the things that what labels, okay, where exactly this data data 0 put it in what clusters it is putting those data 0. So I can check it out with the help of k underscore means dot labels, and when I hit enter, you can see these are the clusters. Okay, so the data 0 that is there, so the first row of data 0, it is in the cluster 1, then the second row of data 0, it is in the cluster 0, and the third row of data 0, it is going to be in the cluster 2. So as we had taken cluster 3, it is going to show 3 clusters over here. Okay, and you already know that what data 0 I'm talking about. Okay, so if I say a cluster 4 over here, then you will see that the data 0, the complete data 0 is going to be processed in 4 clusters. So you can see we have 0, 1, 2 and 3. So we have 4 clusters, and we can put our data 0 rows inside the respective 4 clusters. Okay, according to the according to this clustering algorithm. Now what I can do is I can compare the original data with my k-means data. And how exactly I can do that? With the help of matplotlib. We had seen this object oriented plotting. So I'll use that fig, and then I'll say I need two subplots, right, to compare. In one plot I'll put my k-means clustering algorithm. In the other plot I'll provide my original data, right? So what I'm going to do, I'll say x1 and then x2, and then what this x1 x2 is going to give me, it will give me plot subplot. It will plot the subplots, and you know that subplot needs number of rows and number of column. Okay, so I'll say I need a complete one row. Okay, so I need this box, the complete one row, but I need 2 columns. So I'll provide 1 comma 2, and then I'll use inside that I'll use sh shrey equals to true, and I also provide the figure size, the canvas size, figure size equals to, let me have 10 comma 6. Okay, and then I hit okay to create the blank canvas. You can see, so this is the whole one row, and 2 columns. Okay, so next thing is, oh, I'm so sorry, next thing is I'll say I'll provide x is 1, x1 2. Okay, so x1 dot set title, and this the first one is going to be my k-means clustering algorithm, k-mean clusters. Oh, I'm so sorry. Okay, this is the k-means cluster, and the next thing is I want to provide is the scatter. Okay, scatter function x1 dot scatter, and it needs x and y. So what is going to be my x? I'll just paste it. You know that this is my x, the complete x is going to be data 0 and the all row and column 0, and then I need data data 0, the same the array, and then I'll say the all rows and the column 1, and I'll provide that compare it with, not compare, but this is the k-means, right? So I'll just say c equals to k-means, color the k-means, the clusters, you color it dot labels, and again I'll provide cmap equals to rainbow. Okay, so this is my x1 x2 sorry x1. In the same way I'm going to provide x2, so I'll just copy it, and I'll provide x2 here, set title, it is going to be my original data. So this is original data, and then here instead of k-means label, what I want here, c data equals c data 1. Okay, these two are labels. So this is the label, or these are the clusters from k-means clustering algorithm, and these are the clusters from my original data, and that means make blobs. Okay, so data 1 is also having clusters, and k-means dot labels is also having clusters. And when I hit OK, you will see that you can comparatively see that k-means clustering algorithm is having 4 clusters, and here original data we have 3 clusters. Okay, I hope you understand it.